Hello everyone, this is Ben Cooley, and welcome to my presentation video for my senior project. My senior project was done as part of the carbon fiber recycler device, and the specific part that I worked on was the cutting gears on that device. The purpose of the carbon fiber recycler is to reclaim carbon fibers from carbon fiber composite pieces so that those fibers can then be reused in another application. And the job of the cutting gears is to separate the solid composite strips into smaller pieces that the fibers can then be extracted from. Here's a picture of a previous year's design of the cutting blades. And a problem with it was that the shafts would bind in their rotation because there wasn't enough freedom for them to move and for those spur gears to interact. And also, as the carbon fiber composite strips were fed through and they went between these two sets of blades you see here, there was too much space between the blades, so too much of the fibers, too much of the composite went uncut and was therefore much more difficult to extract fibers from. On the left you can see my finished design of the project with all the covers in place. On the left underneath that chain guard there's a chain that is being driven with this electric motor that drives the gear shafts. And then on the right, you can see a better view of the blades inside there, more closely spaced together. You can see a bearing that I added on the outside here to support the shafts. I added 2 per each shaft. And you can see the successfully shredded fibers here in front once we ran composite through the device. Most of the engineering analysis I did for this project was done with a previous design idea in mind. I ended up changing my design for my project completely between fall and winter quarters, and this analysis was done during fall quarter for the previous design, but it's still relevant because it contains requirements for RPM of the blade shaft and for things like material constraints for the shaft and for the blades, and things that are still relevant to my eventual design. I also considered replacing the chain drive with a belt drive so that it would be more easily adjustable, but time ended up being too much of a constraint for that, and likely it would have cost too much as well, so I did not include that, and I ended up sticking with the chain drive that was pre-existing. I did a lot of calculations for material strength that was necessary for different components, such as the shafts, the blades, and the keys that held the blades on the shafts. In the construction and assembly of the device, the first thing that I did, as you can see on this image reel, was I created the parts that I needed to from scratch, and I made the necessary physical adjustments to pre-existing parts. A notable part that I made from raw stock was I machined these 2 custom spacers. You can see here me parting them on the lathe. Machined these spacers that could fit over the blade shafts and that would space each set of blades out from each other by just enough that they could alternate and that they could mesh together. And a large edit that I did to the pre-existing parts was, this is one of the sidewalls of the housing, and in the previous design the shafts went straight through these holes and fit tightly through these holes because of these brass bushings that you see here, and they just rode on the bushings, and that was the means of lubrication, was just having this solid brass bushing. And as I said previously, that did not allow enough freedom for the shafts to move, and while the shaft should not be allowed to move much, in the previous form with the way that the holes were fixed when the shafts would turn, the spur gears that mated them would bind and they would not turn any further, so it was not functional in that current state. At least not when the housing was all bolted together, because the walls would be a little bit contorted, which I think contributed to that. So what I did here is I installed, as I said, a bearing on the end of each blade to support the blades, and I marked out where holes for the bearings should go. I ground the bearings down on the outside so that they would fit, and I drilled and tapped the holes so that I could mount the bearings with bolts. The first step in assembling the device was to assemble the housing. As you see here, I assembled the entire housing, except I actually left off the top plate of the housing so that I could have easier access to the inside for when I put the blades and other things on the shafts in step 3. But I assembled the rest of the housing and these bearings in that step. And as I said, in the third step, I fed the shafts through the device, and as the shafts were fed through, I put on the blades and the spacers and the different bushings that had to go in there with them, along with the spur gears. There you can see the blades after I installed them, much closer together because there's more of them and they're separated by smaller spacers. And there is the nearly fully completed assembly of the blade shafts, with the spur gears and the spacers and the blades on there, and the shafts fully run through and secured. I completed 3 tests for this project. The first test was to make sure that the blades had enough clearance that they wouldn't bind together. And I had to measure this indirectly because I could not get calipers that would fit inside the housing or get feeler gauges on short notice. So I measured indirectly the space between the blades. And the result was that there was plenty of space between the blades for them to rotate and continue to rotate freely without binding, without wearing on each other, which could not only cause the blades to wear out, but it could potentially lead to disaster when it's rotating at high speed. The second test was measuring the shaft RPM. We used a contact digital tachometer here and pressed it onto the end of one of the blade shafts to measure how fast it was spinning. The purpose of doing this was to then calculate the speed that material was going through those blades and compare that to the feed speed from the rest of the recycling device. And we found that the RPM of the blade shafts was much too high, and so either the electric motor needs to be slowed down or the rotation needs to be geared down as it's translated to the blade shafts. You can see the electric motor running, and it's turning the blade shafts, and there the measurement is being taken. The third test was to determine what was really the main qualifier for success of this project, which was the fiber size found within the resulting chips. This is a picture of the longest chip that I found, the maximum chip length. You can see the fibers stretched out there, but the average chip length was approximately 4 inches, and the desired range was between 0.25 and 0.5 inches. So 0.4 inches fell right in between that range, and so the test was a success, and those fibers that remained in those chips should be long enough to reuse in a loose mat or some other kind of reapplication for carbon fibers. Here is an itemized budget of all the expenditures for this project. I came in well under my budget of $2,500, with just a little over $800 for all the tools and raw stock and materials that I purchased. And here's the schedule from the Gantt chart that was provided, where you can see that most of the work on the presentation, just building the final presentation, was done at the beginning in the form of a proposal, but it was worked on steadily at different times throughout the winter and spring quarters, and more will be added on even yet. Construction was completed almost exclusively during winter quarter when the time was allotted, and testing was completed during spring quarter, also during the time allotted, which was appropriate. And the website and the whole project report were updated throughout the whole year. Thank you so much for watching. Again, this is Benjamin Cooley. If you have any questions, this is my contact email where you can ask me any questions about the project. And yes, thank you for watching.